This is a key on the worksheet on graphing functions using transformations. And in number one, it indicates that you want to graph this absolute value function using transformations. All right, so I'm telling you that I need 4 graphs on this coordinate plane as you graph this function. All right, so let me go ahead and rewrite this function so you can see it a little bit better. So it's negative absolute value of x plus 4, and then plus 3. Okay, so when graphing this function using transformations, the first thing you want to do is to graph the parent function. And so the parent function in this case is the absolute value of x. So remember, when graphing the absolute value of x, there are certain points that I need for you to list. For example, the vertex of the graph is the origin, 0, 0. The point 1, 1's on the graph, the point 2, 2's on the graph, and on this side you get negative 1, 1, negative 2, 2, and then negative 3, 3 as well. So whenever I'm going to go ahead and put 3, 3 here. So when I graph the absolute value, the parent function makes you use a straight edge, so you'll draw a good graph. So you want this to be straight as possible with regards to the absolute value function. So you have these two rays. So there's my parent function. So I'm going to call this number 1. So that's the first thing I have to draw. And the equation of this graph is y equal absolute value of x. Okay, now to graph the next, we're going to go from left to right. Always do the vertical translation last. The vertical translation should always be done last. If it's not, and you have, let's say, a stretch or a shrink, then that's going to affect your final graphing. It's going to not be the correct graph for the function if you don't do the vertical translation last. What I do is I usually go from left to right. So the next thing I see is this negative that's in front of the absolute value bars. So remember, this negative in front is a reflection about the x-axis. So I'm going to reflect. So remember, this is a reflection about the x-axis. Reflection about the x-axis. So the next thing I'm going to do is I'm going to take every point that's on my parent function and I'm going to reflect it about the x-axis. So that's why I wanted you to make sure you listed these points here. And so when I reflect each of those points about the x-axis, the x-coordinate stays the same. It's the y-coordinate that changes. So for example, this y-coordinate is 3, right? When I reflect it about the x-axis, it becomes negative 3 as the y-coordinate. This y-coordinate is positive 2. When I reflect it about the x-axis, it becomes negative 2, and so on. So this y-coordinate reflected about the x-axis becomes this point right here. And then the origin stays the origin, and the same thing on this side. So you're just reflecting it about every point on my parent function. You're reflecting it about the x-axis. And so now when you draw that translation, when you draw that graph, you get this. And so the next thing you had to do, though, was you had to indicate the equation for this one right here. So this would be the second graph you would draw, and you would say number 2, y equals the negative absolute value of x, or the opposite of the absolute value of x. Okay? Then the next thing you see is in the inside, you see a number. So that when the number's on the inside of the parent function, that's a horizontal translation. But remember, you got to think counterintuitive. Most students, I shouldn't say most, but there could be some students that would say, well, I'm going to move this graph. I'm going to shift this graph 4 units to the right because I see a plus symbol. That's not the case. So remember, when you do that horizontal translation, always think counterintuitive. So it's really you're really shifting it 4 units to the left. So every point on this absolute value graph right here, graph number 2, I'm going to shift 4 units to the left. So start with the origin. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So I'm taking every point here. 1, 2, 3, 4. And so on this part, I'm going to shift it 4 units to the left as well. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay? And so I get this now. So let's see. Let me go ahead and draw the ray. Of course, I could have done a better job here. And then on this side, do the same thing like this. And this would be right here. That would be number 3. And so that's going to be, so number 3, remember I'm taking this right here, I'm shifting it 4 units to the left. All right, so that's my horizontal translation. So this becomes y equal, right here, y equal negative absolute value, y equal negative absolute value, and then remember that's how I'm shifting it horizontally to the left, so it'll be x plus 4. And then what I'm going to do is I'm going to do the vertical translation last. So I'm going to take what I just graphed, I'm going to shift it, in this case, 3. So 3 units up. Every point on this graph, I'm shifting it 3 units up. So let's start with the vertex. 1, 2, 3. Then this next point. 1, 2, 3. 1, 2, 3. And over here, do the same thing. 1, 2, 3. And then 1, 2, 3. And so you get this. And so this would be, let's see, let me go ahead and drop this. And so this right here would be the final graph. So that's number 4. And you're going to call it this function because that's what it is. So you can say f of x equal opposite of the absolute value of x plus 4 plus 3. Okay? And that's it. So that is right here. And let me go ahead and kind of use a darker color to indicate the final function, the function I really wanted to end up with, and that is this. I'm going to use this right here. All right, so that's going to be this one right here. All right, and so notice what I did. I used transformations to graph this function. So I graphed the parent function first, and then you go from left to right. You're going to do the reflection about the x-axis, then you're going to do a horizontal translation, in this case, to the 4 units to the left, and they're going to shift it up 3 units. All right, so that was number 1. All right, let's look at number 2. Now, number 2, we have a square root function. And so again, I'm telling you that I need 4 graphs in this coordinate plane. So one of them is going to be the parent function, right? So the parent function is the square root of x. So the parent function is y equal square root of x. And so there are certain points that I need for you to graph for the parent function square root of x. So one of them is 0, 0. Then square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3, right? And so this graph right here is the parent function. So that's number 1, y equals the square root of x. Now, as we talked about before, always do the vertical translation last. Always do the vertical translation last. So let's go from left to right. The first thing I see is this 2 that's in front of the radical. So remember, this 2 is a vertical stretch. Vertical stretch. So remember, this is a vertical stretch. And so basically what you're going to do is you're going to pull this thing. It's like putting your foot here, and you're going to raise, and let's say this is a rubber band, you're going to raise it up. You're pushing it up. You're pulling it up. And so it's kind of like going towards the y-axis, right? Is moving away from the x-axis. And so what's happening is that each of those y values, you're multiplying it by 2. So this y value right here is 1. 1 times 2 is 2. If this y value right here, which it is, I shouldn't say if, since this y value is 2, I'm going to multiply by 2, and 2 times 2 is 4. And remember, the x-coordinate stays the same. Over here, my y value is 3. When I multiply by 2, I get 6. And so now I get this graph. And so this graph right here is my second graph. So that's y equals 2 square root of x. Okay? All right, so all of these y values on this graph right here on the parent function is being multiplied by 2. So you're stretching it. You're stretching this graph. All right, now the next thing I want to do is this horizontal translation here. Now notice it's x minus 3. So it's going to be 3 units to the right. So think counterintuitive. 3 units to the right. So I'm taking this graph here, the graph number 2, and I'm shifting it 3 units to the right. That's what you do. So this endpoint right here, I'm going to go 3 units to the right. 1, 2, 3. This point right here, 3 units to the right. 1, 2, 3. This point right here, 3 units to the right. 1, 2, 3. And then this point here, 3 units to the right. 1, 2. I'm going to estimate where that is. 1, 2, 3. Okay? And so that looks like this now. So this right here would be number 3. So number 3 would be y equal, I'm running out of room, so let me put that right here. So it'll be number 3, y equal 2 times the square root of x minus 3. Okay? So 2 times the square root of x minus 3 is this one. Now the last thing I'm going to do is I'm going to shift what I just graphed, number 3, I'm going to shift it down 4 units because I'm subtracting 4, down 4 units. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So that's on the x-axis. And over here, same thing. 1, 2, 3, 4. And so you get this. And so that is your final graph. So I'm going to go ahead and darken a little bit better. So I'm going to make it a little bit darker than the others to indicate that that is the function I wanted to graph. Notice I got this function by using transformations. I did not use a t-table. That's not what you want to do. Always follow directions. Direction says transformations. All right, so notice I use transformations to help me graph this function right here. All right, and so that's going to be number 4, which I'll call the function itself, g of x, which equals 2 square root of x minus 3 minus 4. All right, and so that is the key on using transformations to graph functions.